Landwise promotes the use of Irrigate Lite software. It is a quick assessment for farmers and it aims to answer the question, do I have a problem, yes or no? It doesn't take down all the information that a performance evaluator would do when they were doing a full assessment, but it does take bucket measurements, speed tests, weighted diameter of your sprinklers, and will produce you graphs to show you how that water is falling onto the ground. It will also calculate distribution uniformity, applied depth, and application rate. So it's a really helpful tool and does have some very good information in it that even if you can't troubleshoot from it yourself, you should be able to give it to your service provider and they should be able to use it as a really good start point to find the problems. Within the software, it does have some really good guidelines and explain how to use the tool. It does all the calculations for you, and on the website for pagebloomer.co.nz you can download worksheets that will step you through effectively all the information you need to gather in the paddock to use this tool. To test a travelling irrigator, whether it's a fixed boom or an irrigation gun or a rotating boom, we put out buckets in a line and we walk our machine over the top of those buckets. So these images have come from Irrigate Lite, and if we look at the one on the left hand side first, we can see the blue bit, that is our wetted width, so that is the total area of the water applying to the ground, and we can see that it extends slightly outside the green area. That is our lane width. So most of these systems are designed to have some overlap. So the next lane would sit directly to the left and right of the green box, and when we applied water we would get a little bit of that blue bit again would come into this green box. So that's showing our overlap. You can see that the buckets are laid out in front of the irrigator and it's a bit further ahead of the wetted area. So when we turn our system on, it can't actually be applying water into the buckets immediately. It has to move onto the buckets and has to move right across the buckets before it stops. Otherwise we don't get true measurements. You can also see that we have one bucket that's sitting outside the lane width and it is capturing the outside of that wetted area to help us with our overlap calculations. If we look at the other image, we can see it as though we're sort of standing in the paddock and looking down the line. We can see that there is 11 buckets in each direction. These are labelled left 1 through to left 11 and right 1 through to right 11. This is really important that we label our buckets and we know which measurement was which, particularly when it comes to doing our overlap calculation. So again, just touching on that overlap, we can see in this image it has been sort of drawn for you. You can see here that this is that little edge of that wetted width, and when a second pass is done as it moves up the left and the right, it will again apply a little bit of water across it as well. When it comes to a performance assessment, buckets are obviously really important, which is why sometimes we refer to these tests as bucket tests. In this image we have got a travelling fixed boom and it is moving up this paddock. On the far right hand side we can see bucket number 11 and you can see it's just outside the intended wetted width or wetted area. We can also see on the very far left just a little bit of wind drift as water is moving across this machine from right to left. The other things to note about these buckets is that their spacings are even. This is important as it helps us understand where our buckets were and we can graph these quite nicely. The buckets should be as horizontal as possible. A bucket on an angle will not give you a true representation of that water footprint hitting the ground. The other thing to watch with your buckets is that you've not placed them in the wheel tracks. So potentially in this image it could be the green or the yellow one, might be on track to be scuppered. If these systems are towing a drag hose behind them, and it might be a rotating system, so a rotating boom, make sure that you move the buckets before the drag hose comes through and knocks them over. Along with putting out our 22 buckets, it's really important that we gather some additional field measurements. So to begin with, pressure. Pressure is really important to measure, and we should take a pressure reading at the pump, and we should also take a pressure reading at the machine at minimum. This allows us to see if there's a big pressure loss through the system, and both of those should have design KPIs, which should be available to us from our irrigation designer. Flow, we need to read the water meter if it's there. This can be tricky if the flow meter is running more than one system type at a time. But if it is only running, say, one gun or one traveller, absolutely take a reading. Is it actually doing what you think it's meant to be doing? The speed test is really important to do. That helps us determine how fast the machine is moving down the paddock. That information is used in the application intensity calculation, but also, is the machine moving at the speed that we expect based on the speed setting we've set for it? To do a speed test, normally we would place two markers 10 metres apart in a straight line next to the hose quite often, and we wait for the machine to move in line with our first marker, and when that same point in the machine reaches the second marker, that's when we stop our stopwatch. We've already talked about this briefly on the previous slide, but we need to understand the wetted width, so how much the machine is throwing to each side of the central line, and the lane width. This helps us determine that overlap. And of course, when we're setting out our buckets, we need to understand how wide our throw diameter is. If our sprinklers throw 20 metres in each direction from our boom, then we need to make sure we set our buckets up at least, say, 25 or 30 metres away from the irrigator so it moves across and over the top of the buckets. When doing a performance evaluation, it's also really important that we undertake observations. So excess water runs to low spots. So do we see ponding or are we seeing runoff? Is that because our soil is at saturation point, or potentially we're applying water too fast and we're exceeding the soil's infiltration rate? We also need to understand the wind direction and its strength. If you can hear the wind in your ears, it's probably too strong and you should stop the test because you're going to be getting quite a lot of water blown off target. The other thing that you should be looking out for is any blockages or broken sprinklers or anything obviously wrong, leaking hydrants, leaking camlock joins, etc. For travelling irrigation system types, we cannot emphasize the importance of overlap. So this is the same machine being tested, but one with the machine expected to have overlap and one without the overlap expected. So the graph on the left, we've said that there is no overlap. And so the outside buckets have got very little water in them, and therefore it's really dropped down our DU because we have a lot of buckets where it looks like we're getting very minimal water. However, if we said that there was overlap, these buckets on the left and right would be being added to each other because we would expect a second pass on the left and the right of the machine, and therefore when we do those overlap calculations, we get the image on the right. These buckets on the far left and the far right, they have had that addition to them, therefore bringing that DU number right up because we've now got a much more even application of water happening on that irrigator. Irrigate Lite will produce us graphs, and these are really useful for understanding the data. So the yellow line is the average from our measured samples for applied depth, and the green line is what our target was. So we can see here that our target was 15 millimetres and we were a little bit off. We're sitting at about 14.5 millimetres applied. We can see that through the middle pieces of left and right, we've got pretty good consistent application, but on the ends we've got a higher application and in the middle it's slightly lower. Those observations can help us understand why we might be seeing these things, so it's really important that we take them.